All right, so welcome back. So this is the part two. We'll talk about the forces I used for the shockwave. So before I start, I just want to say that um, the original project file was using the Axiom 2.2 version of the solver. I had to just changed up the some of the parameters um, because I updated to 3.1. Um, and yeah, so it's not exactly the same. It doesn't look exactly the same as what I had previously for my shockwave effect. Turn it off. So it doesn't look exactly the same as this, but I tried to match all the parameters to what the original 2.2 was, the original settings was, and change some a bit just to keep it look a little bit closer to what I had. Yeah, cool. But for now, let's talk about how all these axiom source shapes. So in here, I have one that sucks in, one that pushes the whole thing into the center. So it kind of helps with the sucking in. So these two are kind of like um, um, working together to create the effect. And the last but not least is the spin. All right, so I'll just quickly put down a null here. Call this source. And so remember we have the pressure as well. And I'm just transforming this up so that it sits right above our ground plane. Cool. All right, so we'll put this aside and we'll build out our little axiom solver. Cool. So axiom solve. Oops, not that one. Whoopsies. Axiom solver. Do you know what? I'm just gonna copy. I'm just gonna copy this guy. Control C, Control V. Perfect. Delete this guy. Toot, toot. All right, so the start frame is at 10:13. So just to run you through the settings I have right now, I'm simulating this whole thing on 5 substeps. The original resolution is 0.03. I'm just setting it to 0.06 just to have a faster feedback. What else? I've multiplied the density on the source, the temperature, as well as the velocity and the pressure. The pressure sourcing is set to frame step, that just so that I could have a lot more pressure without setting too high of a value here for the multiplier. And for the simulation, I have some animation keys on the force. This force is just a downward force, just to keep things contained while things get sucked in. Also, so this is just a counter force. I've got some dissipation, just to dissipate the smoke by the time it gets completely sucked in. Cool. Also, I've got some turbulence and disturbances. Nothing too crazy with all these forces, what do you call them? Shapes, disturbances, and things. Cool. Not sure what these are. Combustion, there's nothing here. Under settings, I'm setting it to 16-bit. Cool, nothing there. All right, let's have a look at what that looks. Cool. So that's how it looks, and I think it's not too bad, especially from the camera angle. So first, let's add the ground plane, and with Axiom, we obviously have one of those source shapes, and we can set it to collision, and we've got a plane, which is so useful. I'll just scale that up a bit. Whoops. Scale that up a bit. All the way. There we go. And let's have a look at what that gives us. All right. It shouldn't be too long. And now we have a ground plane. That's cool. Great. Awesome. Okay, so that's the ground plane. I'll set this here as call GP, and we have one source that I want to talk about first is the sucking in. So let's set this to influence and shape to maybe a sphere. But first of all, we have to make sure that our sphere, the size of our sphere, our influence sphere, encompasses the whole of our simulation. So I'd say this is somewhat enough, maybe a little bit closer like that, tighter. Maybe just a little bit more, something like that. And let's bring that down a little bit as well. So with this influence, this sucking in test. With this sucking in influence, we'll be using the pressure. So with positive pressure, you'll see we'll be adding some, we'll be adding divergence, which is expansion, into our simulation. So let's have a look at what that gives us. So you see we're pushing out all the smoke outwards. We're saying we'll be expanding. We'll give it an expansion from the center and towards the end of the sphere. I think that's pretty cool. But what we want is the reverse. So we'll set this to -15, for example. But we'll do a keyframe. We'll say, I'll remove this for now, and we'll run this again, and let's see the end of our shockwave. So around 1040. So by 1040, I need this to have -15, and by 1030 or 1035, we set this to 0. Cool. Try that out. So that gets directed, and now we have the sucking in. It's pretty cool. So try again. Zoom. Cool. There you go. That's that. So another thing I want to show you guys, because I did it here with mine, I actually have this forces timing. It's just a start frame any duration, and it's linked to the amplitude of the value that I put in here multiplied by the output animation. It's just the output animation is just a fitting the current frame to the start frame, from the start frame to the start frame plus the duration, and it's from 0 to 1. So let's build it out. So let's put down a null and color that red, and we say test force timing sum, and we edit the parameter interface on this. So click select the node, the null node, and select the cog icon up here and edit parameter interface. Cool. And all we need is just an integer for our start frame. Let's delete all these, invisible, and another integer for the duration, and then now a float value parameter for our blend, final blend. So we just put there final blend. This one will be the duration, and this one will be start frame, and then we say default 1001. So under the channels, we can set the defaults here, and the duration, set that to 5 for the default. Perfect. Apply, accept. And we got the default to 1001 and the duration to 5. Cool. So the expression we need to put on the final blend is pretty simple. It's just a fit function. So what we're fitting is the current frame, and we're fitting it, the source min would be the start frame, base relative reference, and the output max, the input max would be the start frame plus duration, and then the output min will be 0, output max will be 1. Perfect. So now all we have to do on the pressure, we don't have to do all these keyframing things, since we're just keyframing it from a value to from 0 essentially to a value. So we just remove that and say our amplitude is 15, for example, our maximum value, and we just multiply that with our final blend. Boom. Cool. So now if we have a look at this guy, chunk. Oh, I forgot. It's working, but we need negative pressure. We need the sucking in force. Perfect. So because we're starting at 1001 with a duration of 5, let's bring this to 1035 with a duration of 5. So we're expecting our little sucking in force to start from 1035 and ramp all the way up to 1040. So there you go, and shrink. Perfect. So that's working. All right, so the next source I want to show you guys is, the next force is the push in force. So we're not gonna give any pressure and stuff like that. But we'll be adding in a force and set this to radial. So this radial force is a force that shoots out from the shape that we provided. So box is shooting out from the box from the pyramid and everything. So I set this to sphere, and it will push it out. It will push out the smoke based on where I put the sphere. So if you have a look at what that does, let's, for example, copy this and set the magnitude, multiply that. It's relative reference. Cool. So we should expect that force to kick in by 10:35. Right, so let's have a look. Play. And I don't really see it because it might be too weak, force. So let's multiply that by 10 and see how that looks. Actually, let's give it a negative value, and let's see, we'll see it better once we, because with a negative value, we're essentially giving it the opposite direction. So play. Okay. It's definitely working. But all right, so all I'm gonna do is set this to a higher value, a positive value. So I'm actually expecting this to be for it to like come out like this radially away from the center of the shape. But by the looks of it, it seems like it's pushing into the center of the shape with a positive value. So keep playing this. See? It's pushing in. So I'm a little bit confused. But I guess that's how it works now. So yeah. So this is just one of the forces that I used. Except I have to be careful with how I shape this, because you see it's flattening my smoke. I didn't really like that behavior, so I'm just making this small enough on the y-axis. That way it just helps bring that whole smoke in to the center. So yeah, something like that. Cool. And obviously we can merge all these forces together like that. Let's have a look. Cool. Very, very cool. Awesome. So the next force that I want to talk about is all right, so the next one is the spinning force. Spinning force. Spinning force. And this will be set to spin. Pretty obvious, eh? So let's just have a look at what that does by itself. Just gonna run it through the sim. Spin. Yes, we're spinning. Zoom, 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 zoom. That's really cool. So just keep in mind that we need a clockwise motion. So by default, this is set to clockwise now. But I think if we set this to negative value, it doesn't say in the visualizer, but what if we can put -1 here? Yeah, so it should spin in the opposite direction now. So play. Actually, for the spin, I want to make it bigger. Yeah, let's make it bigger by 4 more units. That's too big, probably 3 more units. Play. And spin. Yeah, that's spinning. Pretty cool. Very, very cool. And now if we just plug that all in together, put that here, and let's have a look. And play. Zoom, 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 zoom. Yeah, there we go. But let's bring this back to default. And I think our push in is too strong as well. Set that to 15. Save. Run the sim. Boom. Shockwave. And that's pretty cool. With the pressure, I'll add a little bit more. So you see how easy it is to just change the amplitude of our settings with the expression we have here. So all of the animation is set the same. It's just that we're setting different maximum values for all of these. Because otherwise, if we, for example, we've done 1035. Oh no, 1035 is 0, and 1040 is like 15, for example. We're gonna have to like open the animation editor, set this here, and 35. Oh, 35. Boom, exit, and you know that's a few steps to avoid. Now that we have this, just setting the maximum and everything. Cool. Save. Let's go back. 1035, and let's see. Play. Yeah. 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 Yeah, and that's working a lot better. Cool, cool, cool. Yeah, that's very cool. Awesome. So that's pretty much the forces that I've used for the timing of the sucking in and things like that. And there's really nothing much to it after cashing out. So you got this pyro now. So I think there's a few offsets to, let's just have a look. Let's come around this place, and if I visualize this, yeah. So I use different shapes for my forces. So if you have a look at my sucking in, the sucking in is just sucking in a portion of the smoke, because I want, from the camera angle, I want to see the sucking in come from the center and a little bit further away, because I want these to be left behind a little longer. And that's why I have this extra push in, just to push that smoke after we see some movement on the smoke closer to the center. So I think I did animate the radial instead, just to have some offset. So that the sucking in comes in first, and then the push in force comes in a little later. with some delay. Cool. And with the spin, I'm also just spinning a portion of the smoke. Yeah, that's pretty much just what I've done. Cool. Yeah. Also, I have this RS Pyro Bake node. It's nothing fancy. It's just a so I have this Pyro Bake volume node inside, and I'm just baking out the emission volume. So what this does is this sim only has density, temperature, and vel, but when you bake the emission volume, it creates a scatter field and a CE field, and this CE field is what we can use inside Redshift. So if you put down a material network and put down an RS volume material builder, this guy, dive inside, delete that, put down the volume, put down this guy here. So with the volume shader, we can put down the CE here, CE, and we just say to replace the color channel. So we're essentially replacing this ramp with our color value from the CE field. So that's all I'm doing for that shader, and then exposing all these parameters above, and that's all really. Nothing fancy on the Pyrobake. Oops. So yeah. Also this volume sharpen, I think I've mentioned this before. It's essentially just a for loop that loops. If you put down the if you select the Pyro Bake volume and take down the quick setups and select the sharpen volume, this creates a sharpen density here. If you dive inside, there's a volume convolve SOP that just sharpens the current voxel with the neighbors and things like that. Yeah, so that's really it. I just took all these nodes and run it in a for loop like this, for loop with feedback. Just maybe 2 iterations, and boom, boom, boom. Oh, and that's it. Oh, bam. And that's all I did. So it sharpens the field twice, but that's too much already, I think. But yeah, that's all I've done for the sharpen volume. Cool. Yeah, I think that's all for the Shockwave. Really, it's super straightforward. You guys can obviously play around with the shape, with the timing, stretch it out some more, play with the forces. Which one you would want to see more? Probably the spin. Maybe I would want to add a bit more spin to the whole thing, expand the region of the spin effect. Yeah, and maybe even make the first impact a little bit more exciting. I would probably make it bigger or something, but I don't know. And there's a lot of like improvements still to be done for this, and I want you guys to explore your impression of the effects. Cool. So yeah, I'll see you in the next video. Bye.